Hi, I'm Joe Atkinson. I'm a professor in the Civil, Structural, and Environmental Engineering program at the University of Buffalo. Also the department chair, although that doesn't make any difference for this project. My background is in water quality and hydrodynamic modeling. So mostly I look at where water goes and what makes water go where it goes, and also sediment. And sediment transport is a particular interest of this project. I have two other colleagues here at the University of Buffalo who are working on this project, and one in the USGS who is really the fisheries specialist, one of the two fisheries specialists. So two of us are more physical, where does water go, where does sediment go? Two of us are more fish biology people. So the project we're working on is essentially motivated by the question of fish survival, fish longevity, fish sustainability, I guess is the best way to say it, in Lake Ontario. And as many people may know already, fish are stocked every year by DEC, USGS, and so on to maintain sufficient stock to maintain a fishing business. So boat captains will take people out to go fishing in the lakes, and that's an ecotourism draw. So the question is, well, why aren't those stocked fish reproducing, maintaining, a sustainable, why can't we find a sustainable solution to, you stock them, get them going, and then you just maybe limit the catches, but there should be a sustainable population. So the hypothesis that we are investigating is that especially with increased erosion that's related to climate change and high water levels that were experienced in Lake Ontario a couple of years ago. We had record high levels for a couple of years. But it's not just high water levels, but it's really maybe stronger fluctuations that are occurring, we think, because of climate change. So the Great Lakes in general have had the highest and the water levels within the last 10 years in recorded history. So there's a lot of instability, I guess, more instability than what we've typically seen over the years in Great Lakes water levels. And water levels, of course, affect erosion of shorelines. You have wave attack that's also influencing that. So anyway, we have differences in sedimentation. So the hypothesis we're investigating is whether sedimentation is basically covering areas where fish traditionally would spawn. So the fish that we're looking at need hard substrate, and they need to have their eggs need to fall in between gravel where they don't get covered with silt, so that they need to have access to aerated water. So they need that oxygen so that the eggs can incubate, and then the fish can hatch later in the year. So the potential problem that what we think is that there is a layer of fine sediment that is covering those areas where fish are spawning and basically preventing the eggs from being incubated and successfully hatching. So we're investigating that as a process. Is that really what's happening? And we've identified 3 specific regions to look at along the New York shoreline. One is a little bit east of the Niagara River, one is in the Oswego area, and one is up by China Bay. I think that's what it's called. It's up close to the outlet of the St. Lawrence. And that's not the name, and I can't think of the name right at the moment, but it's up near the St. Lawrence. And then in addition to that, once we can identify, if that is a problem, we can look at some potential remedies for that problem. Are there structures that we could put in nearshore areas that could help improve spawning habitat? Mm-hmm. And our tools are going to be, we will be out measuring and taking samples, looking at sedimentation rates in situ, and also doing some hydrodynamic modeling to try to predict what the process ought to be. And then we use the data to verify the output of the models, and then use the models to explore a couple of different scenarios of possible remediation. That's 3 minutes. I don't know.
That sounds very interesting. So is it fair to say that we're seeing patterns where there's just more greater force in the tributary streams, so they're able to move more sediment and deposit it where these fish might otherwise be spawning, and it's sort of piling up there and it's disrupting their spawning habitat?
That's what we think, yes, more or less. I mean, there's a couple of possible reasons for sedimentation changes in sedimentation patterns. The one is that we have I know in Western New York, and I think also in Central New York, we have rainfall that's coming in the summer, for example, is coming more intensely, but less often than it used to. So it's like rainfall used to be kind of like this. Now it's like this.
Yeah.
This is intensity and this is time. That could be causing more sediment erosion in the watershed than there used to be. And then that once that comes out into the lake, it's carried downstream, along the coast. There's a pretty well-defined coastal flow along the New York shoreline in Lake Ontario from west to east. But as it is transported by the water, it's dropping out because it's settling. It's heavier than water. So we think that might be part of the problem. It could be increased erosion, as I talked about earlier, just shoreline erosion. That when the shore moves from here to here, there's a bunch of sediment there that had to go somewhere, and that's generally moved out into the water and transported down, along the shoreline. So one or the other of those we think is probably contributing to higher than historical sedimentation pattern depositions, especially in these areas that fish had historically spawned in.